Okay, so I would like to welcome you guys to this WebEdge Speaks webinar series. Uh, Today's topic is OpenShift, like why exactly we should use OpenShift. And before that, my name is Fahim. I'm with WebEdge Solutions. I'm an Azure DevOps engineer, and we use OpenShift, Kubernetes, Docker containers, etc., and so on. Okay, and we also usually develop microservices, sort of architecture-based applications by using Kubernetes, Docker, OpenShift, and so on. Okay, so first of all, let's discuss the agenda. So today we will discuss what exactly OpenShift is, why use OpenShift, what are the differences between OpenShift and Kubernetes, why use one or the other, what additions we have, what features we have, and so on. And before we discuss what exactly is OpenShift and so on, so how many guys have used or are already using Docker containers? So how many are already containerizing their applications by using Docker? So those guys who are doing that, please raise your hand in GoToMeeting software. Okay, thank you, appreciate it. So it seems like very few of you are doing that. So before we discuss OpenShift, let me actually first of all talk about what exactly containerization is, why we should create containers, and then after that we'll talk about how to deploy the containers to OpenShift platform. Okay, so first of all, let's talk about containerization because OpenShift is basically a containerization solution. So before we can discuss what exactly OpenShift is and how we usually use it, we need to know what exactly a containerized application is. So basically we use something that is known as Docker. So Docker is used to create containerized applications. And what's the meaning of a containerized application? A containerized application basically contains your application binaries, and it also contains your dependencies that are required by your application. So for example, if you need some application server sort of capabilities and so on, we should have them inside this container. If you need other dependencies, like you need to log messages and so on, we should have them inside this container and so on. So containerization basically makes sure that your entire application and all the dependencies that are required by the application should be available inside this container. And this way your application will become portable. So portable means that you'll be able to deploy to pretty much any platform. Like you can choose to use it in your on-premises environment. You can use it on Windows, Mac OS, on Linux, obviously as well. And you can also choose to use it on any cloud platform as well, like on Microsoft Azure or Amazon AWS or Google GCP or Rackspace, Alibaba Cloud, etc. and so on. So basically, it will make sure that your application is portable and it's also cloud ready. So cloud ready means that it should definitely work in your on-premises environment. But if you do plan to migrate your applications to some cloud solution or like some cloud sort of platform, then you should be able to do that as well. So it makes your application future proof because it will be possible for us to run it pretty much anywhere in a on-prem environment, on cloud as well, and so on. And there are more benefits you get with this containerization approach. Like, for example, if we have multiple applications, so say we are working on some ERP type of application, enterprise resource planning. So say you have your sales portion of your application, you have marketing, you have general ledger, payroll, accounts, inventory, etc., and so on. And you might also want to have, let's say, your web front end as well. So let's assume that these are the REST services. Like quite often these days, we prefer creating REST APIs or RESTful services. You can still choose to use your SOAP XML sort of services if you want. So for now, if we assume that these are all the backend sort of services, like you have the endpoints that will let you manage your sales portion of the application. You will have the endpoints to manage your marketing, general ledger sort of portions of your application and so on. And also, let's assume that these are separate applications. Like you can use Java with Spring Boot, or you can choose to use Node.js, or you can choose to use ASP.NET Web API. You can use pretty much any technology to create your RESTful APIs. So these are your backend sort of services. You can also choose to have one more application on top of it that can be your web front end. Like you can use Angular or React, or even HTML with some jQuery or JavaScript sort of code that will provide you with the front end. So the end user will want to connect to this web front end, and this web front end will make various service calls that will be available in separate sort of containers. So basically, containers wise, what you will do is that whatever your technology is, like if you're using jar files, war files, and so on, they'll be available inside the container along with all the dependencies. Like JDK itself is a dependency. You need JDK or at least the Java runtime environment. So likewise, you can choose to have some other containerized application that could use, let's say, Node.js. And you can use this technology and use the Node.js sort of runtime so that you can run the application. So sky's the limit. You can use any technology, and whatever runtime is required to run that application, you can containerize it. Likewise, in this web front end sort of container, you can have your, let's say, Angular or Backbone or React sort of application and so on. And you can definitely choose to add more containerized sort of applications here. Like if your goal is to secure these so that not every person should be able to connect to these backend services, you can choose to involve something else here. Like you can have an authorization or authentication sort of service as well that can use something like, let's say, JSON web token, or you can use OpenAuth, OAuth sort of technique and so on. So basically, you can break down your entire, let's say, ERP type of application into multiple smaller services, microservices, basically. So this way, you're ensuring that all these services, they are decoupled. Let me write down some of the benefits here. So basically, all these services will be decoupled from each other. So decoupling means that they are not part of one giant application that you have to deploy as a, sort of a single thing. Like traditionally, we use .er files that contains multiple war files and so on. So you deploy the whole thing. So it's a single deployment sort of thing in traditional applications. Whereas when you use this microservices or containerization-based approach, you're able to decouple these services from each other. You'll have multiple deployments, multiple small deployments, basically. So decoupling is one of the benefits you get with this approach. And you can also choose to use various technologies. Like you're no longer limited to just using Java for the entire application. Since we have multiple smaller services, so each service can be written in a different technology, and it will still be able to communicate with the rest of the services and so on. So you can use Node.js, Java, ASP.NET or .NET Core, or Python, etc. So sky's the limit. Use whatever technology you want, because once you have containerized your application, it becomes portable, and it's totally independent of the technology that you have used inside that container. So you will be able to use multiple technologies, and this way you can have multiple teams where each team has a different skill set. So one team is good in Java, the second team is good in some other technology, so they are able to create these services, and overall at the business level, the whole application will work because they will be able to communicate with each other by using the REST APIs and so on. And another very important benefit is it's a cloud-ready sort of architecture. So you'll be able to use it in your on-prem environment and also on any cloud platform as well, like Amazon, AWS, GCP, Azure, etc., and so on. So basically, this is a quick overview of containerization. It's sort of a prerequisite to understanding OpenShift concept. And typically, we create these by using something called Docker. Docker lets us create images. Images is sort of a blueprint or sort of a template, or it's a collection of your dependencies and your binaries. It's basically a bunch of files that contains your entire application and your dependencies. And when you execute an instance of any image, that is known as a container. So a container is a running process. It's just the execution of some Docker image. So keeping this in mind, let's cover OpenShift. So OpenShift, like I mentioned, it's basically a container orchestration solution. So orchestration means lots of things. So when you end up having a microservices sort of architecture where you have multiple small components, how do you manage them? How do you deploy them? How do you delete them with ease? How do you make sure that the services that are available inside a container, they are exposed to other applications running inside other containers? So service discovery sort of thing. So how do you ensure that they are able to talk to each other? So management or orchestration is a huge area. So there are several things that we have to usually take care of, and I'll talk about that in more detail in just a bit. So in short, whenever you have to deploy your containers, that is where OpenShift will be very handy. And let me actually show you a diagram as well that will give us a sort of high-level overview of where exactly OpenShift fits in. So this can be Kubernetes/OpenShift. So say you're implementing DevOps, development/operations, or continuous integration and deployment or delivery. So typically you will have some source code in your Git repository. And usually we try to automate the process. We try to create CI/CD pipelines that will check out the code, build your application by using, let's say, Gradle or Maven or .NET Core build process, etc., and so on. You'll want to run some unit tests. And then here, you'll want to make sure that you create your Docker images. So whatever your compiled application is, take all the binaries and also make sure you encapsulate the binaries along with the dependencies. So like JDK, .NET Core, PHP, Python, Nginx. So basically, whatever dependency is required to run your application, you'll want to bundle it up as part of your application inside that container. And then once you have your Docker images, you'll want to deploy these images. And where exactly we deploy them? We deploy them on Kubernetes or OpenShift. And in just a bit, I'll talk about what's the difference between Kubernetes and OpenShift. But in short, here you'll be able to run your applications. And each application will run inside something that is known as a pod. So this pod is a feature of Kubernetes/OpenShift, and it will basically run your application. And each pod basically contains your containerized application. Like you can have your Java with Spring Boot sort of application. You can have your Node.js sort of application inside this deployed container and so on. And you can also have your web front end. Here I've just used the term rich client or rich internet application that represents any modern application that has, let's say, Angular, Backbone, React, Vue.js, Polymer web components, or if nothing else, you can use HTML with JavaScript. And if you need some additional services, like if you need to, let's say, monitor your application. So for monitoring your application, like the performance metrics and so on, like how much RAM is being used and so on, typically we use some solution for that. The most commonly used solution is known as Prometheus. So even this Prometheus can run in a separate Docker container instance that is deployed on this OpenShift/Kubernetes platform. And if you need support for, let's say, tracing your services, like what service is accessing what other service, so what's the entire hierarchy or the chain, and what order they are accessing each other, you can use some solution for that. For example, we have Jaeger. It's a very common solution meant for tracing the applications. So that can also run in a separate container. Likewise, if you need support for more additional services such as Kafka, you need to store your messages or the requests and the responses to some sort of a queue or sort of a streaming service like Kafka. Even that can run in a separate sort of a pod that will contain that particular Kafka or whatever service we have and so on. So typically these additional services, they're also known as the sidecar containers. These are sort of additional services that are required for the sake of monitoring, tracing, logging, etc. and so on. So in short, Kubernetes/OpenShift, this is a deployment platform. You deploy your Docker images, and Kubernetes or OpenShift will manage these for us. Now, keeping this in mind that this is typically the overall picture, the question is, what's the difference between Kubernetes and OpenShift? Because it seems like they are identical. And overall, yes, they are identical. But the difference is that OpenShift, at its core, uses Kubernetes, but around it, it offers, so typically we write Kubernetes as K8s, but around this Kubernetes, it offers various additional services that are not available out of the box with a typical Kubernetes installation. So what are the other services, other benefits? That is what I'll talk about in just a bit. So for now, just know that at its core, it does use Kubernetes. It's very much like saying that we have, let's say, Linux. So Linux is actually a kernel. It's not a full-blown operating system. Like, you need some additional features to make sure that it's operational and the end users can consume it and so on. So typically we use some distribution of Linux, such as Red Hat, CentOS, Ubuntu, Mint, and so on. All the distributions are basically using the exact same Linux kernel, but with additional services around it. So likewise, OpenShift is making use of Kubernetes at its core, but it offers a lot of additional features. They are actually well over 400 features, and you can extend it even further by, it all depends on your requirements and so on. So OpenShift, or even Kubernetes at this point, it lets us implement the microservices architecture, where you can have multiple small deployments. You can manage them separately. It also lets you implement something that is known as 12-factor applications methodology. So 12-factor applications is basically just a bunch of best practices. If you go to this site, 12factor.net, it lists all the best practices that we should have in place when we are trying to implement some microservices architecture. Like we should have a single code base, and we should check out the code from it, build it, create the Docker containers, ensure the side services or the sidecar containers are also managed as well, and so on. The goal is not to go through all these 12 factors. That's basically part of the microservices architecture. For now, just know that when you want to implement the microservices architecture, we typically follow all the best practices and so on. And OpenShift, it does let us follow all the best practices. So it's an excellent platform when it comes to deploying our applications. And in fact, it's basically the entire CI/CD sort of platform. So keeping this in mind, let's cover the next part here. So OpenShift has various editions. It's developed by Red Hat. That's used by almost 90% of the Fortune 500 companies. So it has a huge user base when it comes to the OS, the operating system. Red Hat is basically the commonly used OS. Okay, so it has various editions, like it has OpenShift Container Platform, OpenShift Dedicated, Online, and code-ready containers. If anyone is coming from the older OpenShift version, like version 3.x, there are some changes that are made to the latest version, which is 4.x, something like 4.3 right now. So code-ready containers, it's a new way of using OpenShift if you want to quickly test it out as a developer and so on. I'll talk about these in more detail in just a bit. So first of all, OCP, OpenShift Container Platform. This is the most commonly used edition of OpenShift. It's something that you can set up on your local servers like in your on-prem environment, or you can also choose to set it up manually on any cloud platform as well. So it runs both in public as well as private data centers, your on-prem sort of environment as well as your cloud sort of environments. Here you'll be responsible for setting up everything from scratch, and you're also responsible for updating things manually as well. So this will give you the most control over the entire process, like what exactly you want to install or set up, what features you want to use, and so on. In case if you want to use a simpler way of using OpenShift, you can use OpenShift Dedicated that runs only on public cloud sort of platforms like Amazon AWS, Azure, Google GCP, and so on. And it will be managed by Red Hat. So you will have less work to do. You still have, you can still decide whether you want to update it to the next or the newer version or not. But overall, it's much simpler to set up, but it only works on the cloud platforms. If you want the easiest option, that should still be production ready, and you don't want to be responsible for setting up anything manually at all, in that case, you can use OpenShift Online. And in my demos, in just a bit, I'll show you a few demos. I'll actually use this OpenShift Online. So this way, you do not have to dedicate any server for the sake of setting up OpenShift, etc. at all. You do have to pay for it on monthly basis. So this is a on cloud sort of solution, but it's hosted by Red Hat. So in this case, Red Hat will manage the entire lifecycle, like the new version. Whenever it becomes available, it will be updated automatically and so on. And although we have this cloud, code-ready containers as well, but do not use it in the production environment. Use it as a developer or as a tester, just to set it up on your, let's say, laptop, and just experiment with things and so on. And it's actually very straightforward to set up. You just have to download CRC, code-ready container executable. So you can Google for it, or just go to Red Hat site and download the CRC from there. It will also ask you to make sure you have a valid account. That's totally free of cost. And it will let you download a security key that will be required whenever you use a CRC to set up your cluster. It will always ask you to specify that key. And once you have downloaded the CRC, you just have to use CRC Setup and CRC Start. Just a couple of commands. That is it. It's super easy. And once you have it up and running, after that, you can use OC command line tool to interact with your cluster, deploy your applications, manage your cluster, and so on. But keep in mind that this code-ready containers is not production ready. It's only meant to be used on a single machine as a developer or as a tester. So the cluster will have just a single master/worker. So you'll not be able to have a distributed setup. So in case of the production environment, make sure you use either online or dedicated, or if you want the most control over things, use this OpenShift container platform. Okay, so these are various additions, and actually there's one more addition. If you do not want to pay for anything, and you still want to use something that is production sort of ready, in that case, you can use the open source edition of OpenShift that is known as OKD. It's also known as Origin as well. This is totally open source, but obviously there will be no support. There will be no enterprise support available. You just have to look up for things on public forums, etc. and so on. But this is totally open source. Whereas the rest of them, like even CRC is not exactly open source, but free of cost. But the rest of them, if you want to use them in your production environment, you have to pay for them. And OpenShift offers lots of things. Let's look at this architecture here. So you can have any physical machine. It can be a bare metal machine as well, or you can have a machine with some OS installed as well. It can also be a virtual machine like Hyper-V sort of, or a VMware sort of VMs can be there. You can also use some private data center or even public data center or cloud solution as well. So regardless of where or what infrastructure you have, you can install OpenShift on that. or use OpenShift on that. And OpenShift always, if you do use OCP, you will be responsible for setting up everything from scratch. And there you will have to set up this control plane. So control plane is nothing but just a collection of master nodes. So you need to have OpenShift installed on at least one machine that will act as a master. In fact, in the latest version of OpenShift, that is version 4.x, there by default, it creates 3 masters for the sake of better load balancing, disaster recovery, and so on. And on top of it, you can have multiple worker nodes. So worker nodes is where your containers will actually be deployed, and you can have as many of them as you want. But master-wise, usually we don't deploy any containers to it, although we can, but we don't. And it's only responsible for maintaining the configuration, like how many nodes you have in your cluster, what's the status, what node has died, what node is still working, etc. and so on. So it keeps track of that. And first of all, let's talk about this control plane. It uses a very specialized edition of Red Hat Linux that is known as Core OS. So this Core OS is container ready sort of OS. It's optimized for hosting the containers and so on. So the control plane is always hosted or set up on this particular Core OS based OS, whereas your worker nodes can either use the regular Red Hat Enterprise Linux or also your Core OS as well. And once you have your cluster set up, on top of it, it will offer various services like networking, storage. I'll talk about these in more detail in just a bit. So basically, it does let you implement the entire end-to-end sort of DevOps process, where you can monitor things. You can look at the logs and metrics and so on. It also lets you secure your containers, your projects, and so on. I'll talk about that in more detail in just a bit. You can also use its built-in registry, where all your Docker images will be registered. Otherwise, you can definitely use the public repository like or registry like Docker Hub, etc. and so on. And here we also have CI/CD sort of functionalities available. So basically, it uses Jenkins so that you can write your pipelines, and it should let you implement the entire end-to-end process. This process that I briefly talked about previously as well. Like check out the code, build your application, run the unit tests, create your images, deploy them, make sure that they are monitored, you're able to log the messages and so on. So the whole lifecycle is available here. And for the sake of CI/CD, it does make use of Jenkins out of the box that you still have to configure, and you can choose not to use Jenkins if you don't want to. And it also contains lots of language runtimes out of the box. This is something that will make sense in just a bit when I show you a demo. And you will notice that it's very easy to create these Docker containers and deploy them to OpenShift because OpenShift simplifies the overall process a lot. And I'll talk about that in just a bit. And OpenShift also has its own web console. You can interact with things graphically, or you can choose to run the OC command to interact with your cluster and so on. And basically, you'll be able to deploy your Docker images, and they will run as containers here. So OpenShift has lots of features. Let's actually see some of these practically as well. Let me first of all show you this cluster. I already have this OpenShift cluster set up here. I can open up my web console. Let me actually close this one. Okay, so when you connect to your OpenShift web console, you'll be able to create your project. You'll be able to deploy your applications in various ways. There are tons of different ways you can use. If anyone is coming from Kubernetes, you must have seen that Kubernetes usually offers a very manual sort of approach. So if you are planning to deploy your application, in case of Kubernetes without OpenShift, you typically have to manually create your Docker images And each Docker image is basically created by running a script that is typically named Docker file. So you have to use a Docker build command to create your Docker image. After you have the image created, then you get to deploy your container to Openshift or to Kubernetes. And even before that, usually we have to check out the code from some Git repository, then build it. So build the application. After building the application, you get to create this Docker file script so that it can create the Docker image for us, and then we get to deploy it. So in fact, it's easy if I just show you this particular diagram here. This. Okay, so we have this Git repository. Check out the code. Build it by using Maven or Gradle or some other development tool or a build engine sort of thing, basically. And then you have to create a Docker file script that should create this Docker image for you. So typically, if you are just using Kubernetes, creating this whole thing is somewhat time consuming. Whereas in OpenShift, I'll show you the demo in just a bit. You will notice that it offers the easiest possible ways and also more flexible, complex sort of techniques as well. So based on your comfort level, you can choose to use any technique. So if you want to make things as simple as possible, you will notice that you will have to do next to nothing. It can make things that easy as well. So I'll show you that part in just a bit. Before that, let's talk about this project concept in detail. This is something that is not available in Kubernetes. So Kubernetes does offer something that is known as namespaces, but there's no notion or concept of projects in case of Kubernetes. So project is OpenShift specific. And what you can do with projects is you can create a project just like we usually do in case of, let's say, Eclipse IDE or when you're creating your Java projects and so on. You can create multiple projects and you can organize them. So likewise, in OpenShift, you can create a project that can be composed of multiple related applications. Like if I come back to this diagram, where I briefly talked about microservices architecture. So all these can be separate applications in the same project named ERP. So this will be your project that can have multiple applications, multiple sort of containers. And when you create this project, you'll be able to add users, groups, and assign roles to those users and groups, and specify who should be able to do what, who can deploy, who can run, who can delete, who can modify things, etc. and so on. So security is one of the main benefits you get with OpenShift. So with Kubernetes, although there is some basic security options available, but that is only at the namespace level, whereas in OpenShift, you get to create lots of, you get to assign the permissions, and they are very granular level permissions available, and they are grouped together in the form of roles by default, and you can assign those roles to your users. Let me show you this thing a little bit here as well. So if I go to, let's say, this user management here, you can see these out-of-the-box roles. There are quite a few roles available out of the box, and these are not available in Kubernetes, or most of them, they are not available in Kubernetes. So we have very granular level roles available. We even have a role that allows certain users to extend this OpenShift platform by using something that is known as operators. I'll talk about operators in just a bit, but in short, for now, know that OpenShift, unlike Kubernetes, it comes with several pre-bundled applications. Like out of the box, it recognizes Java, it recognizes Node.js, .NET Core sort of technologies and so on. And you can choose to add even more technologies or languages or runtimes if you want. You can also choose to add various other technologies such as Kafka. If you want to make sure that OpenShift recognizes Kafka with ease, you can install more operators. So this is another main difference between OpenShift and Kubernetes, that OpenShift is a product. OpenShift is a product that bundles up lots of things that are typically used by the companies, whereas Kubernetes is sort of a service in a sense that you use whatever you want. You have to Google for things, you have to see what are the best practices, who's using a monitoring solution these days, so let's install it manually in Kubernetes and so on. Whereas with OpenShift, lots of things are available out of the box, and you can extend it even further as well by installing operators, etc., and so on. So it's a very extensible solution compared to Kubernetes. Even this dashboard is not available out of the box with or this web console is not available out of the box with Kubernetes. So this is available as part of OpenShift out of the box, whereas in case of Kubernetes, you have to manually install lots of additional things and so on. Okay, so basically, security-wise, it's far more superior compared to the plain vanilla Kubernetes. And still, at its core, it does use Kubernetes. So I talked about this thing that it does let us add user accounts, organize them in the form of groups, assign roles to them. In fact, you can also create service accounts, just like we could do even in traditional enterprise applications. So service accounts can be assigned to your sort of containers, so that this containerized application should be given some permission to perform some operation, like should it be allowed to connect to other services or other containerized applications, or create a volume or access a volume, etc., and so on. So you can configure lots of security options at sort of a service level as well. So not just for the users, but also for the services as well. We can create these accounts and assign them permissions and so on. And security-wise, it lets us add users and service accounts in various ways. Like you can use HT password based technique, that is just a simple username / password based key value pair sort of thing. So you can add the users like this, or even the service accounts, or you can also choose to use certificates as well for the sake of authentication and so on. And there are lots of other options available, like we have OAuth. If you're using OpenStack, for that we can use Keystone, etc., and so on. So these are some of the features that are not available in the standard Kubernetes. Here in OpenShift, it's far more superior. So security is very strict here, and you have to configure things manually. Like you can also assign quotas, etc., and so on to these service accounts, like how much RAM, CPU they should be able to use, and so on. Then another benefit we get with OpenShift is application lifecycle management or implementing CI/CD. It's fairly straightforward. It integrates with Jenkins with ease, and you can easily deploy your applications. And even if you don't use the full-blown CI/CD pipelines, you can use this technique to easily build, containerize, and deploy your application. So this is called OpenShift source to image. So if you just have your source code in one of these languages, actually there are lots of other languages as well. So if you have your source code available, that is it. You don't even know how to write the Docker file script. You still want to take the source code, compile it, or build it basically, and then make sure that the Docker images should be created automatically, and they should be deployed as well. And they should be exposed, the services should be exposed so we can access the services. So the whole process can be done with ease by using this OpenShift source to image technique. And let me actually demonstrate this thing practically. So here I already have this OpenShift. Currently, I do not have any project here. Before I show you this graphical approach, let me also show you a bit of the command line based approach as well. So we can deploy our application. So as a sample or sort of as part of the demo, what I'll do is I'll deploy a PHP application that is hosted on GitHub. Let me obtain the repository location. So it's a simple cake PHP. So when I'm starting off with the PHP, after that I'll show you some more examples. Like you can use Python, you can use Java, you can use .NET Core. So basically it's a simple repository. It only contains the source code. So we have our source code available here, and it's written in PHP basically. It's a PHP based application. So if you just have this Git repository and you need to deploy it, you need to create a Docker image and you need to deploy it to OpenShift and so on. With ease, you can use the command line approach, or later on I'll show you the graphical approach as well. So you just have to make sure you first of all create a new project here. So see new project. Let's say test project, whatever. So just create a new project and you will be able to see the project here in OpenShift as well. So we have this test project showing up here. And then next, if you want to deploy your application just based on its source code, you want to compile it, you want to create the Docker image, and you need to deploy it to OpenShift, you just have to use this single command. So OC new app and specify the repository location. That is it. So it will detect what language you have used. And if you recall, I mentioned that OpenShift already has various runtimes, language runtimes pre-installed. So it's able to detect the language. It's able to compile, check out the code. It's able to compile it if it's required. Like in case of Java-based application, compilation will definitely be mandatory. And it will create the Docker image as well, and make sure that the Docker image is deployed to OpenShift. And by default, it will not make the application accessible. You do have to expose your service. It typically shows the command here, cake PHP. And this command will basically expose it. And you'll see this fairly user-friendly sort of URL. You can use this URL. You can actually also go back to your OpenShift web console and first of all, click your project. Go to your networking routes. Here we can see that a URL has been created for the service. You can open up this URL. So by default, this is how it looks like. Eventually, it will show us the default look and feel of that particular application. It's a very straightforward application. And you can also look at your pods. If I go back to this workloads pods, so we can see that the application is now running. And you can choose to do it from the command prompt like this, or you can also choose to we had to use OC new app and we had to do it like this, or you can also do it from the web console as well. So if you want to do it from the web console, you can choose to go to your developer perspective. So we have admin perspective and we have developer perspective. These are different views. The developer perspective will show you something that is known as topology. It will show you how many applications you have already deployed so far. So we have this cake PHP deployment so far. So if we can right click anywhere here and add more applications to this particular overall setup that we have here. So we can choose to get an application from the Git repository, or we can deploy some Docker image, or if you already have your custom Docker file, you can deploy that as well. So let's say I'll first of all start off with the overall explanation of what I'm going to do here. So I'll deploy a couple of services. I'll have a map-based application. It will show the world map basically. And we will also have a backend service that will obtain various points of interest. And this will be accessed by this front-end application. The front-end application will access the backend service, retrieve the points of interest, and display them on the world map. So even here we have sort of a microservices architecture. We have the backend and we have the front end. And we are going to deploy these two, and they are both using totally different technologies. In fact, this one will make use of a ready-made Docker image. I already have the Docker image for this one. And this will make use of the GitHub-based repository. So you can deploy your applications that can exist in various ways, like or various forms. Like it can be a pre-made Docker image, or you can build it from your source code, etc. and so on. So let me start off with this Docker image here. So I'm going to add a project from container image and specify the location of my Docker image. So the sample Docker image that I'm using, that will show the parts, sort of points of interest, parts related information, or the points of interest on the map. So this is the registry where we have this sample containerized application, and it will automatically fill in the rest of the stuff for us. It will even create a root to the application so we can publicly access it. We can choose to uncheck it and do it manually if you want. So click create, and it's pulling the image and it's deploying it. You can see the progress here. And once it's done, you'll be able to open up the URL directly from here. So by default, we don't have any points of interest showing up here at all because there's no backend service that will feed the points of interest to this particular application. So here I can add another project. This time around, I'll use Git. That will basically let me get the application that's supposed to return the points of interest and so on. And notice that when you select Git option, it does automatically detect what technology is used in your source code. So it's connecting to your GitHub repository. It can be Bitbucket, it can be GitLabs, it can be your on-prem sort of repository as well. It can be anywhere basically. So it's able to detect the language or the technology automatically. And you can choose to add more operators to OpenShift so it can recognize even more technologies. And again, by default, it will auto-detect most of these things for us. Click create, and seems like I have to make sure I use a different project since I didn't configure the permissions here. Let me delete this particular project. So it has to do with security, basically. I don't have the project configured for this type of deployment right now. Let me quickly create another project here. Okay, so we should have a project here. Let's go back to this project and go back to this search. And actually, let me also just show you this thing in two ways. First from the command line, then also from the graphical interface as well. Okay, let me redeploy the front end, expose the service, and then I'll show you how to do it graphically as well. Next, I'm going to deploy my second application that will make use of the GitHub-based hosted code. And if compilation or build is required, it will happen automatically. It will create the Docker image for us based on the source code. So we are not responsible for the Docker file in this particular scenario at all. So it can make things that easy for us. And next, I'm going to deploy or expose my service so that the points of interest should be accessible by the front end. And then if I go back to my developer view here, you will notice that we have two applications. And you can see the status here. It's saying that it's currently build running. So build running means it's currently building it. You can actually click on it. It will show you the logs as well. In fact, while you're looking at the logs, it's still basically going, sort of building the image that will be deployed. You can also look at the YAML or the configuration file of your deployment. You can make changes to this configuration with ease. Whereas with Kubernetes, usually this is fairly challenging. You have to create this YAML file and you have to make sure everything is right. So you can use the configuration-based technique to deploy your applications. Whereas OpenShift, it can make things very easy for us, especially because of the web console. And you don't have to use a web console. You can choose to use just the regular command line based approach as well. So we can look at the logs here, and seems like everything is deployed successfully. Let's look at this thing here. So yes, it's saying that it is built, it's up and running. And You can also choose to group these, or before grouping, let me show you the application here. It might take up to a minute for the points of interest to get pulled in by the front end. Eventually, it will show you some points of interest here. And while it's still pulling in the information, let me show you some more features here. So if you have a microservices architecture-based application or project with a bunch of containers or services and so on, you can organize them with ease. You can see the status of your services, whether it's running or not. So blue usually means it's up and running. If it shows you red, it means it failed. If it shows you yellow, it means that it has failed in the past, but it's trying to restart it. And you can also choose to look at more things here. Like if I right click this thing, you can see lots of options here, like we can scale it out. So you can say that you want to have better load balancing and auto failover sort of capabilities. So you can increase the number of instances of this particular deployment directly from here, or you can choose to do it from the command line as well if you want. So basically, it's these sort of features that can make OpenShift a very easy platform. Or you can still choose to use the command line options or the more detailed advanced options, just like we do in case of Kubernetes and so on. So OpenShift is a very easy to use platform compared to Kubernetes. And it's highly extensible. You can add lots of things. Like security is awesome in case of OpenShift. You can add users, roles, groups, service accounts, and so on. So you can do lots of things basically from here. In fact, when you have lots of services, you can also choose to group them as well by creating this application group. So let's say we call it a maps group. So this way we can say that certain services, they are grouped together and so on. So this way you can easily understand your overall architecture. So notice that we have a single group here. So it's not just a visual thing, but it's also the ease of management. Like once you're done with it, you don't need this entire maps application that is composed of the front end and the back end. You can simply right click the group and just delete it. So it makes things very, very easy. And here you can see that now we can see the points of interest here on this map. So the points of interest, they are pulled in or they are retrieved from the back end, and the map itself is running as part of the front end. And once you're done with it, you don't need this application. You can simply delete this entire application with ease like this, rather than deleting one application at a time and so on. So basically, OpenShift recognizes various sort of sources, like you can get the code from your Git repository without even worrying about how to write the Docker file script, how to create your images, how to deploy them, and so on. Or if you already have your pre-built container images or Docker images, you can use this approach. Or you can also have your own in-house sort of repository that contains the list of your images and so on. Or you can build your images from scratch by using this Docker file script, or from the YAML-based configuration file and so on. So basically, OpenShift has awesome support for implementing the entire application lifecycle management, like CI/CD and so on. Here we didn't get any chance to look at how Jenkins pipelines are usually integrated with this one, but it's available out of the box as part of OpenShift. You just have to configure a few things. And it's highly extensible. Like I talked about operators concept previously. So you can recognize additional languages or technologies such as Kafka and so on by adding various operators. Operators are basically pre-bundled applications. It's a sort of a marketplace. You can go to your operator hub site, or you can just go from here, since I don't have security configured right now. Operatorhub.io. It's sort of a marketplace. You can see various applications pre-bundled here that can be integrated with your OpenShift environment. So there are tons of categories available here. Like if you want to use Kafka, you can use this Banzai Cloud Kafka operator. It will let you utilize Kafka-oriented annotations or sort of arguments or sort of labels in your YAML file. So you can choose to use various other technologies, integrate them with your OpenShift environment and so on. Actually, you can choose to add more operators, such as I have this operator that lets me use Eclipse IDE just from this web browser. So you don't need to install Eclipse on your local machine anymore. You can use everything just from this web browser. Like here, I have a workspace here. If I, let's say, go to this one, open this one, you will see that you will be able to see your project. You can add your Java files, C# files, .NET, or whatever technology you're using. It also lets you build your application as well and so on. Even Eclipse is available as an operator that you can use on OpenShift or pretty much on any other platform, such as even Kubernetes as well and so on. So it does take a bit of time to show the file explorer or the project explorer. So basically, you can add your source code. You can build it from here. You can do it from here. You can use Maven. You can use Gradle. You can use pretty much any other build engine as well and so on. So it's a highly extensible platform. So it's Kubernetes, but with lots of additional things. And since it is Kubernetes at its core, it does offer high availability. Like if your application has crashed inside your pod or inside your container, it does restart it automatically. So it's highly available solution. It makes sure that your application is always up and running. And it also offers load balancing. So if you recall, I briefly showed you how to create multiple instances. You can edit the count of the instances and scale it out. So it offers load balancing, it offers scaling options, and so on. And monitoring wise, out of the box, it prefers using Prometheus, and logging wise, it uses Elasticsearch, but you can choose to use additional techniques as well. So for example, if I quickly go to this particular console, here you can go back to the project, look at your workload here, deployment. Let's look at the pod right away. Oh, apparently ended up deleting it. But if you haven't deleted your application that I already have, you'll be able to go to your pod section and you'll be able to see the graphs here or the charts, like memory consumption, etc. and so on. And actually there you'll be able to use a query language as well if you want some advanced query or search criteria and so on. You can use PromQL language. So PromQL is a query language used by Prometheus. So this way you can say, show me the containers that have crashed in the last hour or so, or show me the workload or the CPU consumption of your certain container in the last 2 days or something like that and so on. So basically you can use this Prometheus query language to query it. So OpenShift is Kubernetes, but with lots of additional stuff pre-bundled out of the box. Like if nothing else, this web console, it's an awesome way of quickly deploying your applications from any Git repository or from Docker images with ease. If you don't know how to write any Docker file script or how to run various commands, you can simply use the web console to accomplish everything. You can even configure security permissions, stuff like that as well, and so on. So OpenShift does have lots of pre-bundled operators or pre-bundled applications, and you can also choose to install more as well if you want. So, so in this particular presentation, I've tried to show you some of the features. Any question regarding this part? There's a question regarding, can users and groups be created in managed services like AKS or JKE? Yes, you can, but it's not as granular level control that you get as you'll have in case of OpenShift. So definitely both AKS and JKE, they do offer security sort of features because they are also pre-bundled sort of solutions, but OpenShift definitely has the best possible security options. There's another question regarding why use OpenShift compared to Azure Kubernetes service or Elastic Kubernetes service on Amazon AWS. OpenShift, it has support for various pre-bundled operators, and it has the support for recognizing various language runtimes out of the box. So ease of use. So the ease of use, it's a better in case of OpenShift. Like out of the box, it supports so many different things. Whereas in other sort of technologies, you will have to manually install and configure lots of things. Like if nothing else, just using GitHub-based source code and deploy it. So from source code to deployment in a single step. So I showed you a single command that we have to use, or you could have done it graphically by using the topology option as well. So from a GitHub repository to a deployed Docker image as a single step, that's basically an awesome feature in case of OpenShift. That is not available in case of Kubernetes or cloud-hosted sort of solutions. There you have to manually configure quite a few things. There's a question regarding, can it be used to deploy the same app to multiple clouds? So you can, technically you can, like by using the Jenkins pipeline option, you can definitely do that, but usually you won't have to. Instead, what you can do is you can use Red Hat OpenShift on any cloud solution. Like if you have Red Hat configured on various cloud platforms such as Amazon, AWS, Azure, etc., and so on, you can definitely do that. In fact, you can have your on-prem Red Hat installation, and you can also have a worker node running on Azure or AWS or wherever you want, and load balancing and auto scaling will happen automatically and so on. So you can definitely have a worker node running anywhere. Okay, so basically in this session, we have tried to cover some of the core basics and the differences. Okay, so we do have various courses available on OpenShift. Like if you want to see the administration sort of aspects, including the web console, stuff like that, and so on, we have this particular course. Otherwise, if you're mostly sort of a developer, or you want to, let's say, look at the overall, just the bigger picture, like how usually things integrate and so on, we have this particular course available as well. Okay, so thank you very much, guys. It was a pleasure to be here with you for this session.